Hey everybody, welcome back. In this video, we are going to begin chapters 19 and 22, which covers hypothesis tests. Chapter 19, I believe, is hypothesis tests for proportions. And then for chapter 22, it's for means. It's a very similar process between the two. The only main difference is which value you use, right? A z-score or a t-score. And we've talked about when to use which one previously, right? So we know for our proportions, those are normally distributed. So those will use z-scores, and our means are no longer normally distributed, right? They follow a t-distribution. So we'll use t-scores for our means. So step one, I'm going to move this down here, maybe on this side. And move it on the side, no? Is to state your null and alternate hypotheses. So the null hypothesis is denoted with this H sub 0. We call this H naught. And the alternate hypothesis is denoted as this H sub A or HA. So the null hypothesis is what we're going to assume. We're going to try to reject this assumption with significant evidence. So these kinds of questions are going to say, or are going to ask you to test, that the mean of this population is greater than some number, right? 30 or 35, or test that it is less than 35. So basically, we'll get to this in a few more slides, but whatever the question asks us to test, we're going to assume in the null hypothesis that the mean is exactly equal to that number. So that's what this is saying here. We always put an equal sign for our null value, and we want to fill out the null hypothesis after filling out the alternate, right? So from the question, we'll be able to determine what our alternate hypothesis is, right? If it wants us to test that the mean is greater than 35, we'll put that specifically in the alternate hypothesis. And then we know what to put in the null hypothesis, that the mean is equal to 35 in that example. So again, the null is, right, the question is asking us to test that it's greater than or less than this. That's what we put in the alternate. We're going to try to reject the null, which is what we assume. And again, that's that it is equal to that same value. So to fill out the alternate hypothesis, right, A is for alternate. This is what we want to show. It comes from the question in the paragraph, like I was just talking about. You're going to have three options of inequalities to put in your alternate hypothesis. It will either be less than, greater than, or not equal to from our question. So note, question would never ask, test that the mean is exactly equal to something, right? We're going to be asked to test if the mean or the proportion, right, is less than something, greater than something, or not equal to something. And again, this should come from the question in the paragraph. This is the thing we want to show or conclude. So another important note, right? The null and alternate hypotheses are statements about the population, right? So in this null and alternate hypothesis, we're only ever going to put our population parameters, right? The population proportion is a P, right? Population proportion, and our population mean is this mu, right? So we're not putting p hats or x bars. We're not talking about our samples. We're talking about the population here. So notice this is still step one. We've got 6 steps to go through. So while reading the question in the paragraph, you'll choose the inequality for the alternate hypothesis, which best represents what the question wants to show. Once an inequality sign is chosen, the entire hypothesis test takes on a nickname, and this will be important for step 4 or maybe 5, I believe. So if we choose the less than sign, then our test nickname is left-tailed. We'll call it a left-tailed test. If we have a greater than sign in our alternate hypothesis, then the nickname for our test will be right-tailed. It'll become we'll call it a right-tailed test. And if there's a not equal to sign in the alternate hypothesis, then we call it a two-tailed test. And we'll see why this is later on in one of the steps or in some examples. But basically, when we have a less than sign, just like other questions we've seen, right, that's going to tell us that we want the area under the curve to the left of our z value or our t value, right? So that's why it gets nicknamed left-tailed, right? Just like other questions we've seen, right? What's the probability that the sample mean is less than this? Well, when we were asked a question like that, we found the area under the curve to the left, right? So it's the same thing for these hypothesis tests. And these nicknames just kind of help us remember that. So if there's a greater than sign, we want the area under the curve to the right. So it's a right-tailed test. And then if it's not equal to, well, if we're saying that it's not equal to something, what are we actually saying? We're saying that it could be less than that thing, or it could be greater than that thing, right? So we actually need both tails. We need to find the area under the curve to the left of our cutoff value, our t score or our z score, and the area above to that positive version. So we'll get the area under the curve under both tails. Yeah, these nicknames tell you which tail you shade in under the bell-shaped curve in step 4. So during step 4, we should remember to look back at the inequality sign in the alternate hypothesis for our shading. Recall that we'll fill out the alternate hypothesis first by reading the question in the paragraph and seeing what it is that we want to show. So for an example, right, if our question had blah, 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 something, the percentage of all college students that own a cell phone is less than 99%, then fill out the alternate hypothesis as follows. So the first thing to note, right, is that this is a categorical variable. It asks for it gives you the percentage, right? But, you know, the percentage of college students that own a cell phone, it's either a yes or a no, right? It's a categorical variable. So we know we're talking about, excuse me, a proportion. So if this said, you know, test the hypothesis that the percentage of all college students that own a cell phone is less than 99%, right? We've got our proportion is less than 0.99, right, for that 99%. So that goes into our HA, our alternate hypothesis, right? So now fill out the alternate hypothesis first, right? We've done that. Yep, so we're asking about the percentage of college students that own a cell phone. Again, that's categorical, so we know we're talking about a proportion. And then that is less than 99% is how we got this piece, less than 0.99. So the comparison number that we call it is just going to also be put in the null hypothesis. So obviously we're comparing the same parameter, right? We wouldn't put a mean here and a proportion here. So from the question, we determine whether it's a proportion or a mean, if it's a less than, greater than, not equal to, and the number that they're asking us about. So we fill out the alternate hypothesis, and so we put that same parameter in the null hypothesis. We always put an equal to sign. We're always assuming that the population proportion is equal to whatever number they've given us in the question, right? So we assume the percentage of all college students that own a cell phone is equal to 99% until step 5, where we will hope to reject this assumption. So we don't actually show it, but we would write 0.99 up there in the null hypothesis, basically. And then there's a tip here. The alternate hypothesis is not referenced again until step 6, which is our conclusion. So we're going to fill out the alternate hypothesis first. This is just an example for a population mean. So now let's say we had a question that said test whether the average cover price for all comic books published in 2012 is greater than $2. And then fill out the alternate hypothesis. So it's asking about the average cover price, right, for all comic books. So we know we're using a population mean. And then, right, so this part here, the average cover price is how we determined it was a population mean. And then the question says, is greater than $2. So this is what we want to show, right? We put our greater than sign because of that wording right there, greater than, and it's $2. So that's why we put the 2 right there. And then we would next fill out our null hypothesis, and we'll assume that that population mean of comic book cover prices on average is equal to $2. Again, until step 5, we hope to reject this. And again, the alternate hypothesis is not referenced again. So we would write 2 here in the null hypothesis. All right, so we're finally on to step 2. We have filled out our null and our alternate hypothesis. Step 2 is just to state your level of significance, which is your alpha value. We've seen this before, right, with our confidence intervals. So we're going to use alpha again here. This will be given to you in the problem. It'll tell you to test at the 1% level of significance or at the 5% level of significance. It might also just say use alpha equal to 0.01 or 0.05. So this is the comfort level or of what we would call a rare event, basically. So usually we'll use 1% or 5%, and the significance level is not used again until step 5, where we'll compare it to a p-value. And the p-value is just going to basically be the area under our curve, whether it's to the left, the right, or under both those tails according to our alpha value. So don't be scared by this p-value term. You've calculated this before many, many times. We're just now giving it a name and calling it the p-value. So step 3 is just to state out your statistics, right? Remember that statistics come from a sample. So in our test for proportion example, we've got a sample size and a sample proportion, right? Or in our test for a mean, we'd have a sample size, a sample mean, and a sample standard deviation. So basically, we should be able to pull these out from the questions also. And we just want to write them all down. We'll need them for our test to calculate the z-score or the t-score. So step 4 has 2 parts. Each part is a calculation, right? This is where we're going to calculate the test statistic. This is our z-score and our t-score. Now we're going to call this the z-test statistic or the t-test statistic, right? You can see the calculations are very, very similar to what we've seen before, almost identical. Just note that we're using the p naught here. So throughout this formula, this is just to remind us that this value is going to be the population proportion from the null hypothesis. So we're going to take the statistic, right? And we're going to compare that to what we're assuming in our null hypothesis. And that's true for the proportion and the t test statistic down here. We're going to take our sample mean, subtract it from the mu naught, the population mean in our null hypothesis. Right? The sub-zero in the notation is to remind you that you're assuming these values from the null hypothesis. So again, we're given all these values from our problem. We just need to plug them in and calculate the actual z statistic or t test statistic. So now in part 2 of step 4, this is where we're going to calculate our p-value. We're going to use the test statistic to calculate the p-value. The p-value is just the shaded area under the curve. So remember our tip, we need to look back at our alternate hypothesis at this point from step 1 to see where to shade under our bell curve, whether it's left-tailed, we shade to the left, right-tailed, we shade to the right, or two-tailed, wherever our test statistic is, we would take the area under the curve to the right of it and to the left of its positive, or really to its negative counterpart. You'll shade the area of the tail after where the test statistic is and its mirror image if two-tailed, right? So if you calculate a negative t statistic somewhere here to the left of your mean and it's two-tailed, you would take that area under the curve to the left for that negative value, take the mirror image, right? So it's positive value here, take the area under the curve to the right. Step 5, after we've calculated our p-value, we decide whether we reject or not reject the null hypothesis. We compare our p-value with the level of significance from step 2. Remember, the level of significance is just our alpha value. So we essentially have two cases here. Our p-value can either be less than alpha, which is our level of significance. And if that is the case, then the probability of our sample occurring is small, or in other words, your sample is rare or statistically significant enough to reject your null hypothesis. If the p-value is greater than alpha, then the probability of your sample occurring is more common. In other words, your sample is not rare or not statistically significant enough to reject our null hypothesis. So this is if we have a p-value that is greater than, sorry about that. When the p-value is greater than alpha, then we cannot reject the null hypothesis. Okay, so when your p-value is less than alpha, you can reject the null. When p-value is greater than alpha, you cannot reject the null. So in step 6, we basically take the decision from step 5, and we just write it out into a couple of sentences. So if from step 5, the p-value was less than alpha, then there is significant evidence to reject the null hypothesis. So we say we reject HO, there is significant evidence to conclude our alternate hypothesis. And remember, this is what we wanted to do from the beginning. We wanted to be able to reject our null hypothesis that the proportion or the mean was equal to something, and we wanted to state or be able to support our claim in our alternate hypothesis. So that's exactly what we're saying here in this conclusion. And so when our p-value is greater than alpha, then there is not significant evidence to conclude HA. So in step 6, we write it out in this way. We say we fail to reject HO, and there is not significant evidence to conclude HA. Okay, so in our next videos, we will look at a couple of examples of this.